Today we are going to study the most important chapter for NEET and JEE, and it is also important for CBSE plus 2, that means standard 12. Okay. The chapter is current electricity, and the part 1 indicates video lecture 1. Okay. And in this video lecture we will discuss quantization of charge, electric current. First, I am giving you the idea that you already studied in electrostatics, quantization of charge. Quantization of charge. Charge of any body is the integral multiple of a basic unit of charge. That is quantization principle. Q indicates charge of any body. N indicates integer. And E is called basic unit of charge. That means charge of every body is the integral multiple of basic unit of charge E, and the value of E is 1.6 into 10 power minus 19 coulomb. Coulomb is just a unit of charge. Okay, this is what discussed by quantization principle. Okay. Basic unit of charge E. If E is negative, it is electron. If E is negative, that means minus 1.6 into 10 power minus 19 coulomb. The particle is electron. Electron we will represent with a 0 at the position of mass number and a minus 1 at the position of atomic number, because its charge is negative. Electron's charge is negative and its mass is very negligible. That's why we are giving 0 instead of mass number. Normally we will represent a nucleus as, if X is a nucleus, XZA. A indicates mass number and Z indicates atomic number. Atomic number means number of protons. That means what is the charge of that nucleus. Okay, and A indicates mass number, mass of the nucleus in atomic mass unit U, AMU. Okay, for electron it is negligible, that's why we are giving 0 instead of mass number and minus 1 instead of atomic number, because its charge is negative. And E is positive for proton. Proton we will represent P. Its mass is around 1 atomic mass unit, 1 AMU, and its charge is 1 plus 1.6 into 10 power minus 19 coulomb. Then we will write plus 1, or simply we can write 1 instead of atomic number. And second particle is positron. Positron is produced during radioactivity. Okay, and it is represented by E. Instead of mass number it is 0, and instead of charge atomic number we will write plus 1. Plus 1 indicates its atomic number, or simply atomic number indicates charge of a metal, charge of an element, so plus 1 indicates its charge. Positron is actually what? Just like that of electron, but whose charge is just opposite, positive charge. The positron is the antiparticle of electron, whose charge is equal to that of proton and whose mass is equal to that of electron. Simply, basic unit of charge is possessed by these particles. Okay, and charge of a body is normally expressed according to the excess and deficiency of electrons in that material, because positron, we already told that what positron is developed or produced during radioactivity, and protons are bound inside the nucleus with strong nuclear force. That is the basic, strongest basic force in nature. So protons are normally will not be free from an element. So electrons are revolving around the nucleus in atom, in elements, so that electrons can be ionized. Okay, so deficiency or excess of electrons actually indicates charge of a body generally. Okay, if charge of a body equal to 1 coulomb, then how many electrons are there? How many electrons are there in the body? How can we find? From quantization principle, we can write N equal to Q by E. Q is 1 coulomb and E is 1.6 into 10 power minus 19 coulomb. Coulomb will be cancelled. Reciprocal of 1.6 into 10 power minus 19, that we have to calculate. 10 power minus 19 will become 10 power plus 19 divided by 1.6. We can write 10 into 10 power 18 on numerator by 1.6. 10 by 1.6 is 6.25 into 10 power 18. So we can say, to get 1 coulomb charge, there should be excess or deficiency according to plus or minus. Okay, 6.25 into 10 power 18 electrons in a material. So we can simply write plus or minus 1 coulomb equal to deficiency, or plus indicates deficiency, minus indicates excess. Deficiency or excess of 6.25 into 10 power 18 electrons. 6.25 into 10 power 18 electrons. And you always remember that reciprocal of electronic charge or basic unit of charge is 6.25 into 10 power 18. This will help you to convert joule into electron volt into joule, energy units of energy simply. Now we can study what is electric current. I. You can give capital I or small I. For steady current, we always use capital I generally, and for varying current, we use small I. Okay, whatever may be the letter. Okay, symbol. What is electric current? Electric current is the rate of flow of charges. Rate of flow of electric charges. That is electric current. Rate of flow of electric charges. Okay. So, from the definition we can write I equal to Q by T. And Q we can write NE by T. Q indicates charge, T time interval for which the charge Q flows. From this definition we can say SI unit of current. I is ampere. One of the 7 basic units in SI, ampere. From here, 1 ampere equal to 1 coulomb by 1 second. 1 ampere equal to 1 coulomb by 1 second. From here we can say 1 ampere is the current. 1 ampere is the current when 1 coulomb charge means 6.25 into 10 power 18 electrons flows per second through a conductor. It is 1 ampere. But this definition is not the SI definition that you will study in the chapter Magnetic Effects of Current or Moving Charges and Magnetism in terms of force between two parallel current carrying conductors. Okay. This definition we will get from this equation I equal to Q by T. This is the SI unit of current. And what about CGS unit? CGS unit is electromagnetic unit. Why electromagnetic unit? In electricity, there are two types of CGS units. Electromagnetic unit EMU and the electrostatic unit ESU. Electrostatic unit says conditions of unit of charge when it is at rest. And electromagnetic unit indicates units of charge or units of quantities in electricity when charge is flowing, because moving charges produces magnetism. That effect also included here. That's why electromagnetism. Okay, we are discussing that. We will discuss in another chapter, moving charges and magnetism, and there is one more chapter, electromagnetic induction. Both electricity and magnetism are interrelated. Okay. Now here we are discussing current electricity. Charge is flowing, so we have to take only the electromagnetic unit. We can't take electrostatic unit here. Okay, whatever it may be. CGS unit of current is biot, BI. Or the famous scientist that law you may heard, Biot-Savart's law. Okay, Biot, B-I-O-T, or it is also called ab-ampere. Ab-ampere. Okay, 1 ab-ampere equal to, or 1 biot equal to 10 ampere. Then CGS unit of current is 10 times greater than. CGS unit of current is 10 times greater than SI unit of current. So 10 ampere means 10 into 6.25 into 10 power 18 electrons are flowing through the conductor per second. Then that current is 1 biot or 1 ampere. This is what CGS unit of electric current. Now, instantaneous current. Instantaneous current. Current is actually, electric current is actually rate of flow of electric charges. So instantaneous current I we can write dq by dt. dq by dt, rate of flow of charges. So differentiating q charge with respect to time, or this we can write limit delta t tends to 0 delta q by delta t, or simply I equal to dq by dt. This we can do only if charge q is given as function of time. Then only we can use this equation to find instantaneous current, dq by dt. First derivative of charge with respect to time. And from here we can say crossing dq equal to I dt. Small element of charge equal to current into small time interval. So integrating on both sides, net charge flowing q equal to integral I dt. Integral dq gives q, that is equal to integral I dt. This is done when current I is given as function of time. Current I is given as function of time. Then only we can use this equation. Okay. And normally we know that integration and differentiation is done when there is a function. Otherwise, you can use numericals directly. Okay. And what about average current? Average current, IAV. Average current, IAV equal to delta Q by delta T. Or you can write Q2 minus Q1 by T2 minus T1. Difference in charge flown by time interval. That is the average current equation. Okay, you please copy the points. If charge Q equal to 2t square plus 5t plus 3 coulomb, find instantaneous current at 2 seconds, average current from 0 to 3 seconds. Try to solve it by pausing the video, okay? Okay, and now first part is to find instantaneous current. I instantaneous means dq by dt, first derivative of charge with respect to time. So d by dt of 2t square plus 5t plus 3. Differentiating 2 into 2, 4t plus 5. Derivative of constant is 0. This is I instantaneous equation. And question is time at 2 seconds. So at 2 seconds, I instantaneous equal to 4. Instead of t, we can give 2 plus 5. 8 plus 5 is 13. 13 ampere is the instantaneous current. You got it? Now I average from 0 to 3 seconds. To find average current, we have to use this equation. Equal to Q2 minus Q1 by T2 minus T1. 0 to 3 seconds. So 0 is T1, T2 is. So we got the numerator. I average equal to, denominator we don't know. Okay, substituting, numerator we have to find separately, and substituting denominator 3 minus 0, and we have to get Q2 and Q1. Can find Q2 and Q1 here. What is Q2? Charge at 3 seconds. Equation of charge is 2t square plus 5t plus 3. So we can use that equation. At t equal to 0, the charge is Q1. Then Q1 equal to 2 into 0 plus 5 into 0 plus 3. We will get 2 into 0 is 0, 5 into 0 is 0. So we will get Q1 is 3 coulomb. At t equal to 3 seconds, charge is Q2. So we have to give 3 instead of t. 2 into 3 square plus 5 into 3 plus 3. We will get 2 into 9 plus 15 plus 3. 2 into 9 is 18 plus 15 plus 3. We will get 18 plus 3, 21 plus 15 is 36. 36 coulomb is Q2. Then you have to substitute the values of Q1 and Q2 here in the equation of phi average. So we will get 36 minus 3 by 3. 36 minus 3 is 33 by 3. 33 by 3 is 11 ampere is the average current between 0 second to 3 second. No question here. If current I equal to 3t square plus 4t cube plus 1 ampere, find one charge flows through a cross section of conductor. For cross section I will use now CS, now onwards CS cross section of conductor between 0 to 2 seconds, and how to find number of electrons passed in this time interval, that means 0 to 2 seconds. Pausing the video, try to solve. Okay. First question answer. We have to find charge and current is given here as a function of time. Current is given here as a function of time. So we have to use integration total charge Q equal to I into dt. I into dt. What is current I? You can write here. Integral time from over to over 0 to 2 seconds. 0 to 2 seconds. So we have to integrate 0 to 2 seconds. Limits of integration 0 to 2. 3t square plus 4t cube plus 1 dt. Integrating 3 into t cube by 3 plus 4 into t power 4 by 4 plus 1 into dt is t, giving lower limit and upper limit. 3 cancelled, 4 cancelled. We will get t cube plus t power 4 plus t, 0 to 2. And giving upper limit and lower limit, we will get total charge Q equal to t. Instead of t, we have to give 2 cube minus 0 cube is 0 plus 2 power 4 minus 0 power 4 is 0 and plus t2 minus 0. If the lower limit is 0, so we no need of thinking about it. Just to give the value of upper limit to the variable, we will get directly. Okay. So 2 raised to 3 is 8. 2 raised to 4 is 16 plus 2. We will get 26 coulomb is the charge. Okay. Yeah, I think you got it. Okay. And question number 2. Number of electrons passed in this time interval. To get number of electrons, we have to use quantization principle. Q equal to NE. Then N equal to Q by E. What is Q? 26. What is reciprocal? Here it is 1 by E, right? Reciprocal of electronic charge is 6.25 into 10 power 18. Or you can divide with 1.6 into 10 power minus 19. Okay. 162.5 into 10 power 18 electrons, or you can write 1.625 into 10 power 20 electrons passed from 0 to 2 seconds through the cross section of the conductor. Okay. Then we can use the quantization principle here. to find number of electrons passed through the conductor. Now we can study two entrance points. Okay, I'm writing here note. Okay, note, first point of the note is that we already studied that instantaneous current I equal to dq by dt. And in electrostatics, electric charges and fields, you studied that lambda equal to dq by dl. Okay, lambda means linear charge density. Linear charge density means charge per unit length. So lambda equal to dq by dl. From here we can say dq equal to lambda dl. So I equal to lambda dl by dt. dl is the small length or distance travelled by the charge in a time interval dt. Small distance by time interval, that is speed of the charge flow, lambda v. V is the speed of charge flow. Lambda linear charge density, v speed of charge flow through the conductor. Okay, second point of the note. Current I equal to lambda v. So lambda equal to I by v. We already studied that, or we will study in the chapter electrostatics, that electric field due to an infinitely long straight wire is E equal to lambda by 2 pi epsilon 0 into r. We have a wire which is charged positively, either positively or negatively. From the wire there is a perpendicular distance r and there is a point P. That electric field is found using this equation, E equal to lambda by 2 pi epsilon 0 r, infinitely long wire. E equal to lambda by 2 pi epsilon naught r. Okay. For lambda we can give what? I by v. So E equal to I by 2 pi epsilon naught r into v. Instead of lambda I am giving I by v. We will go to the denominator. I already studied that kinetic energy of a charge in a potential difference V is QV. Kinetic energy of a charge in a potential difference capital V is QV. So kinetic energy we can write half mv square. Half m into velocity square equal to charge into potential difference. Small v indicates velocity, capital V indicates potential difference. Don't get confused, okay? So from here we can say V equal to 2 will go the 2qv by m. Here v square, we are eliminating square here, so we have to give square root on the right hand side, okay? Root of 2qv by m. So we can substitute equation number 2 in equation number 1. 2 in 1. Then we will get E equal to I by 2 pi epsilon 0 r root 2qv, root of 2qv by m. And then m will go to the numerator. So we can write E equal to I by 2 pi epsilon 0 r, or I by 2 pi epsilon naught r root m by 2qv. What about direction of current. Direction of current. We are assuming a conductor whose ends are connected to a cell, a battery. This is the positive terminal and here it is the negative terminal. Metal atoms are too big. So valence electron gets small attraction from the nucleus. That's why they are almost free. So using this cell we are providing electrostatic potential energy. So due to this negative repulsion of this negative and attraction of this positive terminal, an electric field is developed due to this potential difference in the conductor, and direction of electric field is always from positive to negative. This is the direction of electric field. So due to this negative terminal, the free electrons starts drifting, or they tend to flow opposite to the direction of electric field. They tend to flow opposite to the direction of electric field, from negative to positive. So direction of current is taken opposite to the flow of electrons. That is, in the direction of electric field. The direction is taken conventionally. That means to understand the concept according to the convenience. Okay, we are taking current is in the direction of electric current is in the direction of we can say electric field, or we can say opposite to the flow of electrons, or we can say from positive to negative, or we can say from higher to lower potential, Once more, all the points are same. Direction of current is from positive to negative. That is in the direction of electric field. That is opposite to the flow of electrons. That is, flow of current is from higher potential to lower potential. So positive terminal is taken as higher potential and negative terminal is taken as lower potential. Okay. But normally direction of current, so conventionally direction of current is taken from higher potential to lower potential. Then what is the direction of flow of electrons? Flow of electron is from lower to higher potential. It is the very, very important point for board exams and for entrance exams too. Electric current from higher potential to lower potential. So flow of electrons is from lower potential to higher potential. Okay. Now, current possesses direction, right? Yes. In the direction of electric field. Is current vector or current is scalar? What's your opinion? Is current a vector or scalar? Current is actually a scalar quantity. Why? Not vector. Because it does not obey vector algebra. Once more, current possesses direction in the direction of electric field, but it is scalar, considered as scalar. Why? It does not obey vector algebra. It does not obey vector algebra. For example, have a conductor, 3 ampere is flowing in this direction, and 5 ampere flows down, 4 ampere flows downward. Okay, what will be the current in this arm? 3 plus 4 is 7 ampere, right? Here, angle between these two is 90 degree. Now, 3 ampere, another conductor flowing 3 ampere towards right, 4 ampere coming in this direction. What is the direction of current in this arm? Here angle is reduced between 3 ampere and 4 ampere. Still the current in the is going outward, is current going outward is 7 ampere. Okay, now 3 ampere is flowing in this direction and 4 ampere is coming from the 4 ampere. What about the current in this arm? It is also 7 ampere. We can't use vector algebra here. Okay, if current is vector quantity, so we have to use the equation to find resultant a square plus b square plus 2ab cos theta. Resultant are equal to a square plus b square plus 2ab cos theta. A and b are two vectors with an angle theta between them. Here angle theta changes between 4 ampere and 3 ampere. Still the current, total current is 7 ampere. So here we are not applying vector, we can't apply vector algebra. So current is scalar quantity. Okay. Now we got a question. Question number 3. Electric current is, the options are, first one scalar, second one vector, third one tensor, fourth one none of these. Which will you opt? Which is the correct one? If question came like this, if question is coming like this, you answer current is tensor, not scalar. Why tensor? Current is actually scalar, right? Okay, according to NCERT textbook, it is scalar. Nothing said about tensor in NCERT textbook, but still, if a question is coming for NEET or JEE, then we have to opt for tensor. Why? Tensor is a scalar. Tensor is a scalar with a plane. Tensor is a scalar with a plane. Why? Electric current. We are taking a conductor like this. Okay. If current is flowing in this direction, here we can say a plane, cross section, area of cross section. And the direction of area of cross section is perpendicular to the plane. So this is the conductor, this is the area of cross section. Direction of area vector is always perpendicular to the plane. So, tensor is a quantity. Tensor is a quantity, is a scalar quantity which has a direction, and a plane in which it acts. Once more, tensor is a scalar quantity. Tensor is a scalar quantity which has a direction and a plane in which the quantity acts. Okay. So current is tensor quantity. If there is nothing, and if there is an option like this tensor there, then you have to opt scalar. It is the right answer. Okay. Okay. Now we are going to study orbital current. Orbital current. Consider a charge Q. A charge Q is revolving along a circular path. Whatever may be the direction, clockwise or anti-clockwise. And small r is the radius of the circular path. Orbital current is the current developed in one circulation. When a charge is revolving or circulating uniformly. Once more, orbital current is the current developed when a charge is circulating uniformly or when a charge is in uniform circular motion. That current is called orbital current. So, time we can take time period of circulation. Current in one circulation, that's why time period of circulation. So, orbital current I equal to charge by time period. Frequency nu equal to reciprocal of time period. So, we can say Q nu. And time period, you know that 2 pi by omega angular velocity or angular frequency. So nu equal to omega by 2 pi. So we can write here q omega by 2 pi. And linear velocity, speed of charge, speed of circulation equal to r into omega, radius into angular velocity. Linear velocity, angular velocity rotation is here. Here it is the magnitude only, no vector. We are considering the magnitude. V equal to r omega. From here we can write omega equal to v by r. Linear velocity by radius. So this equation we can rewrite qv by 2 pi r. qv by 2 pi r. 2 pi r is the circumference. So, current into 2 pi r equal to charge into speed. Charge into speed. Current into 2 pi r. 2 pi r is the circumference. Now, for orbital electron. Orbital electron means electron which is revolving around the nucleus. Instead of Q we can give E. So we will get orbital current I equal to E by T or E nu or E omega by 2 pi or EV by 2 pi r. Then V is the velocity of electron in its orbit, R is the radius of electron's orbit, E is the charge of electron, I is the current developed in one circulation of the electron. Okay, this is what